start. So, welcome guys to my presentation about code generation and annotation processing. Last talk, so what a bummer. The the conference is almost over, but we're having a good time, right? I hope you still have energy, because like I said before, I'm going to show a little bit of technical details at the end. I'm not going to go like that deep, but I want to show you like with live coding like actually works, and I'm not just like talking lies here. And meanwhile, I'm also going to show some snippets, like some part of code, so at the end you will be familiar of what I'm talking about. So yeah, I'm Cristian Serje. I'm working currently in Check24. It's quite a big company in Germany. They basically do like comparisons, like from services, from insurance until travelings and stuff, you name it. I work there in the Android team. You can find me pretty much everywhere with Serje, like Instagram, Facebook, GitHub, you name it. But in Twitter, you can contact me as Serje Cristian. You know, somebody stole my nickname, so I had to change it there. Maybe that's why I don't use it that much, so you will see that. But still, if you want to have some contact later, you can add me over there as well. So we're going to talk about annotation processing and code generation. So we have to have clear, actually, what annotations are, right? I think that all of us have like seen annotations already, but let's just go through quickly. So annotation is a form of metadata, provide data about a program that is not part of the program itself. Annotations have no direct effect on the operation of the code they annotate. This is actually the official definition from annotations from Oracle. Long story short, it is metadata for a Java code and also describes the usage of an element, like let's say deprecated or override and so on and so forth. And also describes the nature of an element, let's say if it's a web service or whatever. So this is actually quite clear. We have worked with annotations already, at least the basic ones, override, deprecated, and so on. But what if you will want to write your own annotation? Say that you will write your annotation at droidcon A or whatever. It's actually quite simple. A custom annotation is as easy as this. This is a snippet of the code that I will show later. So you basically have to do public interface and the name of the annotation, but you have to have a prefix at. So as soon as you do this, it's already an annotation basically for Java. And you have to have some configurations. For instance, this at target, which guess what? It targets what the annotations will annotate. In this case, it has an element type, which it means that this annotation can just annotate classes. This is what the element type is doing. In the target, you can also have an array of element types, for instance, a method, and also the type, and so on. I don't know if you have seen the annotation inject. The same annotation, you can use it for parameters, for methods, for attributes, for classes, and so on and so forth. So in this case, I'm just using element type, so this bundle bind annotation will be valid to annotate classes. It has also retention, which is going to say until when the annotation will be alive, so when it will be discarded later for the compiler, or if you will need it on runtime and so on. So as soon as you do this, congratulations, you already did your own custom annotations, and then you can write your own annotation processor. But not really. First, we have to think about if we really need it. You know, like why you will need to write your own annotation processor, like to generate code, if you actually, you can write it yourself. You know, you could copy paste or write methods or whatever thing, like the usual things that we are used to. So for that, actually, I'm gonna say like what was my personal motivation. It was like one day I was working, and then the product manager came and she said, you know what, you have to make a big application form, you know, the typical form for the username, email, and stuff. Usually are like 4 fields or whatever, but I had to do something. It was for banks, so I had to do like 200 fields, you know. So all of those fields, they had to have validations. They had to have a typical message. They have to have immediate validation. So if you were leaving one field to another one, I had to show an error. they have a lot of constraints and so on. So the validation for all of that form in real time, it was like a pain. So I was thinking, this is more or less what I had to do. So I had to create a really complicated form. I had to validate classes, validate methods, validate all of those fields that they were all right. I had to do immediate validation, as I mentioned. So if you were, if there was an empty field and then you were leaving to another one, or if it was accepting number, then you will just apply like, okay, this email is not valid, or you should be just number or whatever. So I had to add it on the V3 observer, but just imagine to add that manually for 200 fields and all that manually, you know. So all of those changes were like really hard. It was really hard to track the changes, and to maintain it would have been a pain. So I wanted to look for a validation thing that it will do it for me, a validation library. So for you to have an idea, this more or less, this is a custom view that I had to do. This is, well, this is in German, but it says basically like insert a valid date. So here basically I'm using Butterknife here. It says day, month, and year. Pretty simple. But it was not actually that simple, because this custom view was just one of the views of the 200 I had to do. It was the day have to be a real day, so it could not be, let's say, 32. The month, it have to be a real month, so of course it cannot be 12 or whatever. The year, also a real year, and also the whole string, the whole concatenation of the stuff, I have to parse it somehow and notice that it was a real year. So maybe it could not be, you know, like 30 of February or whatever. Besides that, also maybe that field, it had a constraint that I had to do, like it cannot be before than the current date, or maybe I didn't want to pass another 6 months or whatever, so I had also to have a constraint that it could not be older than another date picker. So I had to compare dates. Long story short, there were a lot of constraints and everything just for this small field. So, and I had to show different error messages for every kind of constraint. So that was a pain, and then I started looking on Google, like, okay, there should be a library that will ease me that stuff, that I don't want to write all of those constraints myself. And I was surprised that I didn't find anything. Well, actually, I found one, but it was using reflection, and I wanted to avoid reflection at all costs in Android because I didn't want to cause, you know, performance degradations on runtime, but instead on compile time. So I was like, okay, I want to, you know, to do something that it will not, that it will be faster also when the application is running. I didn't, so I started writing my own. I knew how the annotations processor were working already in advance, but I didn't went like that deep into it. I mean, I knew how Butterknife and Dagger and so on were working, but then I was like, okay, I think that I have to write my own. And I did, and it was the final result after I wrote this validation library. As you see here, I have the same stuff than before. I have my custom view. Here I'm injecting it, and I have 3 constraints for this one. I will validate if it's a date. If it's not a date, then it will show, please insert a valid date. If it's not before than the current date, it will show me the date selected cannot be before than the present date. And I also have a constraint of 2007 days that cannot be like past 2007 days from the future. And I will say the date selected can be after 66 months from now. And that's it. You know what is really cool about this is like it's self-documented. I mean, if one of you go to the code and just arrive there and see the view, you really don't have to scroll down and see like, okay, how I'm converting to date and how I'm comparing to, you know, to 2007 days. Where are that logic? You don't care about that anymore. You just annotate and the constraints are there. It's like self-documented, and so later any other developer that will come will know what is going to happen and what the app is doing. So why I'm telling you this story, because of course you have to think about your motivation and when actually you should use it. So why you should use it? Avoid boilerplate. We know how Java is like a boilerplate language, like that's why a lot of people are using Kotlin and stuff, which is also awesome, but still you want to avoid all of this copy paste, or maybe that tedious code that you're like, oh, I have to write this validation again. and over and over again. So you can avoid it. Also understand how other frameworks such as Dagger, Butterknife, or such work in the background. Who is using Dagger here? Or Butterknife, AutoValue? You see, like most of us, we're using some of these code generation libraries, and you should actually know what classes are doing, what classes are those libraries creating on the background, because anyways, all of those classes are going to your APK. So somehow you actually should recognize what is happening, you know. And so yeah, with this, you actually, maybe you have a convention and a convention of the code, of your code, and you can create a fork of Butterknife and change the name of the generated classes and so on, if you have a better knowledge of how it is those libraries are working. So yeah, you can worry about things that really matter. In my case, I don't have to care about validation anymore. I just I have to care about like the different logics and stuff, but then I say, okay, what are the constraints of this field? I annotate, okay, it cannot be min, max, and stuff, and that's it. By the way, here I just have 3, but I have like 15 constraints. And depending on what constraints the view has, then I can just annotate, and that's it. I know that in the background, all of those things are going to be validated for me. So I can worry about things that really matter. It's fast generation code, no reflection, as I mentioned before. It's not like reflection is bad. It's just like a thing that in Android it should be pretty much avoid. You don't know how it's gonna be in different devices. So I wanted to. It's fast code generation. It's like you wrote the class yourself. So you pretty much know what is gonna happen. It's highly configurable. I mean, just imagine an empty board. So you can write there as much as you want, any kind of classes. You can write any file. You can write Kotlin, whatever thing the processor can write for you. It's going to increase you the speed of development. Of course, you will have to write eventually the processor, but also you will have to write an utility, or you will have to write whatever thing that is going to do those, in my case, those validations for you. But once it's done, then the speed of development is just going to increase because you will not care about those things anymore. It's highly scalable. You can, the processor is just going to write any instructions that you tell the processor to write. So you can scale it after that as much as you want. This actually really is something important because you can trust a lot more what the processor is going to write than what you are going to write in the because if you can refactor something, but maybe you forget something, or maybe you have a typo, or if you are like copy pasting, you can also miss something. But the processor is never going to miss anything. As soon as you are not, the processor is always going to do the instructions right as you program it to do. So you can completely trust those generated code. So yeah, now let's go to the real deal. We're going to talk first the annotation processing, of course. So for the annotation processing has the annotation processing tool, which is built on the Java C. This is basically the one that is going to find and execute your processor. So your processor is basically just one class, right? And this APT is going to find that class. You just have to register it. So then the processor knows where to find it. It finds it and then executes it. That's it. And then later I will show in deep details how we are going to do that. Like I mentioned, everything is happening on compile time, so we don't have to worry about performance degradations on runtime. All of this was actually introduced in Java 5, but it was pretty bad, and then they made like the richest API on Java 6 in December 2006, and it was like quite ignored for a while, even though it's a powerful tool. I mean, it was ignored for a long time until the last couple of years that actually people are like, okay, this actually is useful and stuff. But everybody was like used to reflection and so on, so it was ignored for a while. The annotation processing tool is the one that it will let you generate Java files, as I mentioned, but it has also something cool that most likely you will use. It is like it gets messages on compilation. So the annotation processing is going to do exactly that. It's going to process annotations. So you can send to the application that is trying to compile, or to the application that is executing the annotation processor, you can send messages and avoid compilations completely. So let's say that you want to compile, for instance, you can create an in-progress annotation, And if you want to compile something on production, for production, then you can send an error like, okay, you know what, I will not compile because this class is annotated as in progress, so I cannot send it to production. Things like that. All of those things you can, and it's not even about generation of code anymore. It's about like processing the annotation, you know. Or for instance, which one of you have had those comments, to-do comments, that they are there for ages, and you're like, oh yeah, I had this to do. I think that most of us have had those to-do that never are done or take a long time until you're like, okay, actually I will do it. Maybe you can create an annotation, like add to-do, and as an attribute, a date. And if it passes that date, the processor will not compile it. And it will say, you know what, this to-do already passed the current date, so you should either remove it or whatever, but it will not let you compile it, you know. Or maybe a better deprecate method, so it will be removed until whatever day, otherwise it will not compile, and so on and so forth. The thing is that these messages tool utility will let you, you know, have like a better convention on your teamwork as well, in my eyes. As I said, it will just cause performance degradations on build time. But this doesn't mean that you should write just like a sloppy code there and like an infinite loop or whatever, because of course you don't want to wait 1 hour until your code is running or your app will run. So just take care of it, write it nicely and stuff, because anyways you will want to maintain and have like a nice compilation time as well. So yeah, and now this is more part of the demo that I will show. The processor, I will put it, it's gonna run in a different, it's a different module. It will be the compiler module. Usually you can put it like in a different jar and then just execute it. So it's a plugin Java, it's not plugin Android. So just forget about Android for a second. This is totally, it's even running in a different Java virtual machine. So it's not Android. How do you do that in Gradle? Just, I guess you already know, you just do apply plugin Java instead of apply plugin Android, and that's it. This module is the one that will contain the processor, as I mentioned, and it's executing its own virtual machine. That is quite cool, because I don't know if you are used to, for those that have worked in backend or something, if you are used to any library like Guava or whatever, that are like pretty heavy libraries, but you don't want to add them usually on Android because they are heavy, and then they will, you know, include all of the thousands of methods that it has. All of those libraries, whatever, you can use that on the compiler module, because any dependency that is here, it will go to the final APK. So you can add everything you want, like heavy libraries, whatever, just it's plain Java. So it doesn't even have like views or anything, because it's not connected to Android at all. So you can add any library or tools that you want here, and you can be sure that they will not go to the final APK, right? So I just say that it is running on its own virtual machine, that everything is happening on compile time, it's on build time, and so on. So how will I really analyze classes if they are not classes yet? You know what I'm saying? I mean, they are not compiled, I have no instances, they are no objects, they are not really classes, they are just basically files, because they haven't been compiled. So here, we have to change our mindset a bit. So the way that we are going to work with processors are not like really classes, but they are mainly, elements. So here we have to, just imagine, I don't know if you have worked with XML files, and you know that you have the DOM, and then from the parent you can jump to the child, and the child knows about the parent, and so on. So it's like a tree. So more or less we are going to work in here, and we are going to work with elements instead of instances, classes, and so on and so forth. So this is more or less the representation that for now on, everything that is related with annotations, we have to have in mind these kind of representations. So a package is not going to be a package anymore, but a package element. A class is going to be a type element. A variable is going to be a variable element, and so on and so forth. The main executable element, and so on. So everything that the annotation processor will receive is not going to be classes, but elements. So we have that clear. Now let's continue about another snippet that I will show later. This type element is basically a class element that it was annotated with this bind that I showed before, bundle bind. And I want to get all of the elements that have annotated this bind value. So basically it's going to give me the variables that have this bind value annotation. And if they have this bind value, I will add them on the list. That's pretty much it. This is what this stuff is doing. I will get the classes that are annotated with bundle value. Well, this is already the classes that are annotated with bundle value in type element, and then I will get all of the elements from that class. I will get which element has bind value and add them on the list. That's it. Now let's move to the processor. This is really where the one that is doing all the work. To do a processor is actually quite simple. You just have to extend abstract processor. That's pretty much it. You just have to configure it a bit. For instance, you have to say which supported annotation types can handle, because the processor don't want to look for all of the whole spectrum of all of the classes. You have to know of all of the annotations that your application has, but you have to determine okay, you should look just for these annotations, So this is what this method is gonna do. You have to say which supported source version can handle, like the Java version. Usually you just do latest supported and that's it. It has this init method, which is gonna give you some tooling, like for example, for the messenger that I told you to send messages to the one that is executing, or the filer that it creates the file and so on. And it has the process method. It will say that it's like the main method there. And it's where, the money is. Here is the one that is really executing the processor. But since we are talking about annotations, we can resume all of this like this. It's basically the same. I'm extending the processor. I'm saying which supported source version, just latest supported. This is by default, so you can also remove that one and they will be the same. And it has also supported annotation types. Here you will do your annotation type, the fully qualified name of the annotation that you want the processor to process. And that's pretty much it. Then you will get all of the elements that are annotated with this, and it will return you the elements. This already, as soon as you do this, then the processor will look for those classes and those annotations. That's pretty much it. So I mentioned before that we have to register the processor, so the service loader will look for it. That's quite simple, actually. You just have to do in a file meta-inf services, create this file, javax annotation, that processing, that processor. And in there, you just put the fully qualified name of your processor. And that's it. The service loader will go to the processor and execute it. It's quite simple. If you have more than one processor, you can just create new lines with the new names of every processor that the service loaders should execute. If you don't want to do this, you can use also autoservice as a library from Google. But you can just do it in a file. I will show you later how it is done. It's quite simple. But this is basically doing the same in the background. You annotate autoservice, the processor, and it will create the file for you and stuff. So now this is the error handling. It's about these examples that I was giving you. It is gotten on from the processing end that is on the init method that I was mentioning before. And it shows a proper error to the third-party processor executor. It was those examples that I was telling you that you can say you cannot compile because this and that. Remember that this is not actually an exception. The exceptions can happen anytime on the processor, but it's going to happen on the Java virtual machine. But that is not really saying anything to the developer that is executing it. So these messenger are just messages to the developer that are executing the annotation processor. Like it should be meaningful or messages. The processor should still return something. I mean, it cannot crash because otherwise it will not send the message. So you have, if the processor has an issue or something, cache it, everything there, but it still should return something. And this is how you do it. You do processing M, get messenger, print message, the type of error. In this case is error. I want to show like in red, and in this case it will show there should be at least one field binded. That's pretty much it. So tools to keep in mind before I do the demo, it will be Java Poet, Java Parser. These are the ones that they will help you to write the code of your generated file. In here, I will just show plain Java, plain string builders, so like our old friend. But you can take a look of those ones. They will help you to, to build the strings better and stuff. Google Java format, which is going to format your code, as the service that I already mentioned. So just for you to have an idea of how Java Poet works, if you will want to do a hello world, it's quite, I will say complex, but it's another learning curve. It works with builders, so you have to do like method, which kind of method is. It's a main, and then fires, you add, it's a public, a static, turns a break, and so on and so forth. So all of this generate class hello world. Like I said, I will not mention this. I just wanted to keep in mind that there are tools that are doing that for you, but we are going to show here just plain string concatenations. So, okay, so all talk, no action. Let's check here. I will just add a timer because we have still 15 minutes, right? Can you? Okay, good. This is actually quite a simple example. Basically, it is it's just two activities. I just have 4 fields. Let's say name, last name, address, and email. And basically, what it's gonna do, let's say that I have here a name, Cristian. Can you see that, right? Yeah. Address, I will say Dubai, and here email. And then it's gonna just send this information to a second activity. It's quite simple, as you see there. But I'm adding the name of the field plus the value of the field, right? So here you can see the name of the field is address text, a name text view, and so on and so forth. And what I am doing is basically putting the extra in the intent. So I'm doing address text and so on. This is basically what I'm doing. But then let's say that let's say that this is the information that you want to send to the server, like in a JSON file or something. But then let's say that actually you don't want to send address text view, but you want to say address text to remove the view part, because that doesn't matter for the server. But you want still to maintain the same name on the variable. So then you can edit here, or you can refactor it. But here I'm going to do it manually. You can edit here. It will be address view. Of course, you have to remove here. If you will refactor, of course, it's going to do it for you. And then you can refactor it here. But also you have to change the string. This string is actually not part of the view, so you will have to be able to modify that. So then you have to do a string here, oh yeah, view, and then you have to go to each one of them and do the same. Maybe you will have a typo, maybe not. You have to trust that you are actually doing all right. And then run it. It will be now, it will be same stuff I will do. Address, email, show labels, and now I have address text. Okay, so far so good. But then later you will have to make another changes, or maybe this is just for 4 fields, but maybe you have 20 or something. You're like, okay, you know what? Why am I always modifying this put extra? It can be done. It could be done automatically for me. So then I'm gonna write a processor that is gonna write all of this stuff for me. And then I can point like which view actually I want to pass to the second view, right? So as I mentioned before, I was showing before this one. We are already familiar with this one. It's basically it's just a class that is on the class level. So all of the classes that I want to send to the second activity have to have this bundle bind. So let's do it. I will just annotate this one with add bundle bind. And done. Okay, first step done. Now I want to also be somehow, I don't want to send all of the views that are on the bundle bind, but I want to select the views that I want to send to the next activity. And that's why I created this other one, bind value, which you can see the target is an element type field. It means that it can just be, it can just annotate fields, of course. And then let's do the same. So then I want, in this case, I want to send a bind value. That's it. And I want to bind this one and this name text, and I also want to this one, for example. Now I have these three. And let's add this one as well. Okay. Okay, 4. Cool stuff. Now let's go to the processor. Now we have already the annotations, quite basic stuff. Now I want the processor to really read these values, these attributes, and create me this part of code. Of course, because of lack of time, I already have my processor. As you see here, I have the compiler module. Look, that is a Java class, a Java module, and this is the processor that I wrote. Basically, what is happening here, it is the processor is going to look for all of the classes that are annotated with bundle bind, and it's going to return me a collection, these bundle binds. Okay, I will go through all of the collection, and I'm going to generate always the code. You know, the typical generated, auto code generated, so generated code, so don't modify and stuff because it will be overwritten. And it's going to generate me always a class. The class that is annotated, concatenated with bundle binder, so I know how it's going to be the class now. In this case, it will be then MainActivity bundle binder, it looks like. And then I start, you see, it's typical just string concatenations. I'm doing public class, the class name, and I start concatenating open class and stuff. Then I look for the get annotated fields. In this case, it's going to look for all of the fields that have bind value. So if I look here, this is the part that I show also on the slides. I'm just going to go through the classes, all of the fields that have bind value, right? So nothing new here. And then I will append the code that actually is doing the put extra. And here I'm generating the code, public, static, open the activity, and you see here is where the put extra is. Then I take the name of the element, I set the parameters, and at the end I start activity. So basically I'm doing the same thing that it was before, but I'm doing it like with the string concatenations, and that it will be dynamically generated. So that's it. I don't have like anything else here. Here I'm generating the code, the file. It creates the source file in the target package and so on. That's pretty much it. But I said that we have to register the processor, right? So just for you to see, I have here the meta-inf services, JavaX annotation, and here we have the processor already registered. So far so good. If there is a trick that you can right-click and then just do copy reference, and the copy reference is going to give you the fully qualified name there. But here I also have to say which supported annotations I have to look for. In this case, it's a bundle bind, right? So I just have to do supported annotation types, make here, and I will just do the same trick, bundle bind, copy reference, and that's it. Now my processor will put that it can handle bundle bind annotations, and it will execute the process method. So let's see if it's working. We go to MainActivity. Now, in theory, we can remove all of this. We don't need this anymore. And according to the processor, there should be a main processor. If you see here, I'm not lying, there's no MainActivity, what was the name? Bundle bind. There's no, that class is not there, but if I build, I can rebuild here. Then if I look for classes again, if it works, let's see, there's not. I don't know if I'm missing something. Let's see. So bundle bind, supported, bundle bind. Yeah, it should be built now. So MainActivity bundle binder. You see, this was actually a generated class. If I go here, you see that I have already all of the code that the code was auto-generated for me, and it was the code that I had before. So now it's a lot simpler. I just do get open activity. I can do MainActivity.this and the activity that it should open. It labels activity.class. And that's pretty much it. I run this, and it will have exactly the same result as I had before. So we have already, you see, I add this, and that, and that's it. But it is a lot simpler now because I can remove this. For example, now the name text, it will not be there. If I run it, you will see that the code is automatically removed. If you notice that the code balls are automatically removed, I don't have to care about the names, anything. Everything will be automatically done. If I already run this, and you see that the name is not there because it has not the annotation bind value. So how cool is that? So now let's say that I have another, for instance, I can, now it has no validation, and if last name is empty, I send it, and you see like an empty string there. I'm like, okay, this data is actually not necessary, it makes no sense. So actually I can modify the processor. As I said, it's like highly scalable. So I can go to the method, like all of the string concatenations, and I can create a condition that it should not be added. So let's add a condition here. Before the put extra, I will do if the text of the string, the length is not bigger, it is bigger than 0, then add it. Here is a typo here, and that's it. If I run this again, I will open the generated class. Where was it? Okay, if I run this again, you will see that now I just had to do, took like 10 seconds. I wrote the condition, and as you see, I have a condition now for all of the fields that I want to add. I just run it. If I leave any field empty, like this one, last name, it will be automatically ignored. So you see how simple it is to modify, and how I can trust that actually it's going to take the proper name, and it's not the same as I will compare every if and copy pasting, but it's going to take the proper name and it's going to compare it and actually add it on the length. It's going to create the condition, I mean. So let's go further now. We already have a proper stuff running. Well, as you can imagine, now I can change the name of the variable. Now let's say that I want to add text 1 or whatever, or I can add again text view in each one of them. So now I will add view. I don't have to do anything else. I just run it. And here, I didn't have to care about any type or anything, and here is going to have text view already. Because, of course, the generated class is always going to take the name of the field. So that's one of the cases that I'm saying, like, you can really trust about the code that your processor is generating. So now let's go further and create one. We have still like 5 minutes. Let's go further and create one of those tools that I told you, like for instance, this on progress. So every class that is in progress, you don't want to compile. So let's make it for scratch. The in progress annotation is basically the same as bundle bind annotation, because it's going to target classes. So I'm going to just copy paste this class, and I'm going to do in progress class. Done. I have now an in progress class, and I want that the processor always, when it finds an in progress, it will return me an error like, you know, I cannot compile because this is in progress class. So I can actually, instead of bundle bind, I can do something like this, but I will do annotation handler, let's say, annotation handler, whatever. And this one, okay, now I will make it as a variable better here. So this one, it will be annotation handler. And this one is actually going to be, because I still want to check for the bundle binds. So I want to do it as a list of classes that are extending, let's say extends, annotation, because I want to handle both. I want to handle a bundle bind, and I want to handle as well the in progress class, right? So here I'm going to use a list of new array list. As you see here, I'm even using Java. It's not even in Android. So I do in progress class, and that's it. So now, okay, and now I will add this in a for. I will go, okay, it's not going to be annotations handler, but annotations supported. And here, this one, it will be, this one, it will be a class that extends annotations. And here, it will be annotation handler. Okay. Okay. So here, basically, what I'm going to do is like go through all of the classes that I can support, bundle, bind, or in progress. I'm going to close this, and that's it. I didn't do like any much there. Just that now, instead of just supporting bundle bind, I support also in progress. But there is also something missing, and it's this. I have also to tell to the processor that I have to handle in progress one. So I go to this class in progress. I will copy the reference, go back, and just put it here. And in progress. Now the processor knows that I have to look for in progress. And of course, I have to send a message. So let's add it here. And I will do like if annotation handler, I don't know, is equal in progress. If the annotation is actually a progress class, then I will use the processing env. I will send a message to the developer saying like, with type error and saying, nope, you can't compile, or you can compile in progress classes in production, for instance. And that's it. If I leave this like that, nothing is going to happen. The application is going to run, and it's all right. You see, it's running. But if this one is in progress and some developer actually said, okay, bundle bind, but and makes this compile, if everything goes all right, I want to compile now. You see, now there was a compilation error. If I look what happened, I can see here, nope, you can compile in progress classes in production. So actually we know that is the power, like how good it can be the processor, not just for creation of files, but also for just convenience. Like if you want to have some rules between developers, you can create your own annotations, and the processor can just read what the annotations are doing and just retrieve any kind of messages or create any kind of files in the to the developer. So yeah, that's pretty much it. And then now we are done with the time, and yeah. So if you have other questions, you can let me know. So I think that you can use this one as well.
I think it's fine.
Yeah.
So it was very good. Thank you very much, first. I really like it.
You're welcome.
And yes, the generated code is always the same, but as a developer, I cannot trust in a string. I cannot test those methods. I'm just appending strings. If I make a typo in my generator, and for some sort I commit it, then the whole company cannot build anymore because I made a mistake.
Yeah.
So it's very difficult for me to put in the CI. I check that the compile code actually compiles. So the generated code compiles. So is there a good practice for that?
Well, there is actually. I don't know why it should not happen to you that often, because the processor, it should not be written that often, overwritten, you know, because as you're not going to have that many typos. Maybe you have it meanwhile you're developing it, like you have a typo or whatever, but as soon as it's done, it should not have any more typos, because it's always going to rely on whatever you tell it to write, as I was mentioning before.
Or it becomes more complex, and then I have methods, and my method actually has a bug. I do not discover things later, but how can I have a unit test on that generated code, for example, so if I make a change, I want to make sure that it's still...
Yeah, actually, you can, not exactly on the processor, but you can create unit tests on the classes that it's going to generate, of course. Because I couldn't mention it here, but you have also rounds, so you can run also several times the processor. So first it will generate the classes, and then you can, after generate some classes, you can even generate another ones that can be dependencies of the generated ones, and so on and so forth. So you can actually create even unit tests for the generated classes. You know what I'm saying? You can read, exactly. So things like that you can do. It's like I was saying, it's like a really powerful tool, but I would say that it should not happen that often. I mean, unless you are modifying the processor like several times, but usually the processor is like generating. Of course, there will be bugs, or you can extend things. But in my opinion, I'm not sure if it will be that much needed, like a unit test for the generated classes, because as soon as it is done, you know, it's always going to be the same. You know what I'm saying? There's no... Of course, there can be things that you might miss, but they should be done on the like at the beginning. You know what I'm saying?
But in the sample, for example, on the dates, no?
Yeah.
Some countries might have different way of funding those dates.
Uh-huh.
So the moment you add a new country that you support, your business logic was 1, now it's 2. So you actually, a developer will change the generated code.
Mm-hmm.
You want to make sure that you didn't break the other country. So if you have business rules on the generated code, then definitely it can change, and you want to make sure.
But again, those things, it have to be done on the processor, because the processor, it will know, like, I'm expecting just a GMT, you know, and then if the developer sets something else, you can set an error message like, it already passed the to-do because the timing is whatever time GMT, and then the processor will know, okay, you know. But there are things that, like I'm saying, you can think ahead, or you can just say, like, set the timing in whatever time, or maybe you can add another parameter, which you can add the locale and things like that. But again, all of those things you can think in advance, because the processor is actually not gonna like have an issue. It's just how you program it to answer to, or how you program it to process those annotations. You know what I'm saying? Yeah. No, that actually, yeah, that is also something I wanted to mention. You can generate classes, but once the class is done, it is go to like bytecode and stuff. There's like Project Lombok that is doing something like that is actually modifying classes, but it's not really, it's not really the things that the annotation processor should do. It's usually, you can maybe extend it, or, you know, add the package and everything. It will be like dynamically done, but it's not really done for creating new classes. You had a question, right? Or you? I think you were first. Okay. Yeah.
I want to ask, like, the annotation you created for in progress, that classes shouldn't combine that have in progress annotation.
Sorry, I cannot hear you again.
You created an annotation for in progress.
Yeah.
That would throw an error when you try to combine that
Yeah.
class. Something that can be skipped somehow, like annotation processor can process those annotations that we don't want to be in compilation process. Like if some class contains in progress annotation, we don't want it to be compiled, so that in progress class can be known in memory.
Well, the thing is, or either you compile your whole project or not. The thing is that what you could do is just throw a warning. You know, I mean, anyways, if you skip it and if you don't use it anywhere, it's all right. But if you have it as dependency, if you have it like include somewhere else in some other class, then it's not going to work because you didn't compile it, right? So you can throw warnings as well, which is going to run your app, but it's going to appear as a warning. So those were these kind of errors that you can also show, the types of messages that you can show. So not just error, but warnings as well, and so on. But yeah, you can also, let's say, something that it would be cool is like, depending on the build type, you know. So this in progress one, depending on the build type, it will be skipped. If it's in development, it will not. You know, things like that. So yeah.
For that, how would you do that? So how do you get the build config, the compiler?
You could add it as a parameter, for instance. So you know that this, yeah, you pass as parameter. You can add always in the annotation. This was simple annotation. It was in progress, but you can of course send there a number, a type, whatever thing.
You mentioned
Yeah.
Run an annotation processor, say, my annotation, or somebody else's annotation processor generates a bunch of stuff, and I can feed it to another annotation processor.
Yeah.
To go through and run. Does that work effectively, or do you
Well, they have like phases. I mean, it depends of if you really want or not. I mean, but if you really need it, it can happen. You know, you can actually write a class which is gonna auto-generated class, which it has its own annotations, and then afterwards process it again that generated class. You can do it, but of course, it always depends of your needs. You know, I mean, if it's really needed or not.
we're trying to get the root architecture to actually try to be able to use that same SQL we've written in root to try to run that on the server so we don't have to run it twice.
Yeah.
Which means I have to write my own annotation processor, generate it, and then hand it over.
And then hand it over where?
To hand it to root.
Ah, okay.
The idea is that we would annotate DAOs, so that would then generate something that's room annotated, goes into Android, and then another annotation processor would sort of hand that over on the server side.
Okay, okay.
One DAO class I have the same thing running in Android and in the...
Yeah, like I said, it works with rounds, so you can actually round several times the processor if you want, and then it's pretty flexible. But of course, the complexity starts to get bigger. But yeah, you have different chances. Questions? So, no more questions. So thank you, everyone.
The last goodbye for droidcon this year. Thank you so much for being in the last few minutes here. Thank you for attending. Thanks all the speakers.